Okay, chapter 9 now, starting chapter 9. We're going to talk about conic sections and analytic geometry. Analytic geometry is just this idea of using things in a plane. We've been using this idea for a while now, of plotting things in a plane, right? Now, we're going to talk about the ellipse, which is one of the conic sections. Here are the objectives for today. How to graph ellipses, how to write equations of ellipses, how to graph ellipses not centered at the origin, right? And how to solve applied problems. Should be a fairly simple piece of content here. If you haven't seen ellipses before, you may need some extra practice. And I'll refer you to a couple of exercises. So, they don't really introduce what ellipses mean here in the book. They just go straight up to defining them. And when we talk about conic sections, I think it's interesting to talk about what does it mean when I say conic section, right? So the idea of a conic section is, well, if you draw a cone, right? Let's say I have a cone. And let's say I cut this cone, and I get like, let me use a different color, maybe let's say a black plane that goes through and cuts this cone, right? Then when I look at my cut is like this, right? Is a circle, okay? If I were looking from above here, let me put some eyes here, so that you know I'm looking from above. Then that plane looks a little bit like a circle, right? But if I do tilt that plane a little bit more, okay, let's say I cut at a different place but also a little bit tilted like that. Not my best plane, not the best plane I ever drew. Can do better. There you go, it's much better. Then because you were tilted, it's like your circle got tilted, right? And then your vision now is a slightly elongated circle, something like this. And that's an ellipse. So that's why these are called conic sections. These are shapes that you get by sectioning, right? Cutting a cone with a plane or something. Okay? Okay, so that's what ellipses are. That's how where the name conic section comes from. And then you can define them differently by saying that they are the set of points. You have the foci. Use the foci, 2 points, right? A focus and another focus, plural focus foci, whose sum of the two distances to the two foci is a constant, a fixed constant number. There's some cool videos online of people building ellipses using this property. I'll share one with you. But let's go to the main points here. You have this F1 and this F2 being your foci. One focus, two foci, right? It's Latin. The ellipse is the blue curve, right? This is the ellipse. The red ones are the foci, right? F1 and F2, and then the center will be the midpoint here between the foci. And I'll do like a different color, maybe a green. This is the center right here. Okay, so this is an ellipse. Some names here. The longest part of the ellipse, so it's an elongated circle, right? You elongate it in one direction and you sort of shorten it in the other direction. So the direction in which it's longer, it's called the major axis. So this is called the major axis, and this is the minor axis. Okay. It could have been the opposite, right? It could have been the major axis in the horizontal, and the minor axis in the vertical. The vertex is this little tip here. This is the vertex, and the other vertex at the bottom. Okay, on the horizontal case, the vertex here, the vertex here. So it's the tip of the longest, the farthest point from the center, I'll say. This is what the vertex is, right? And you say the plural is vertices, right? Okay? So just a little nomenclature. Let's keep going. Now the equation, that's the mathematical part about it. So the equation of an ellipse is this or this. So you'll note that they change A and B, change places. Okay, because they always want A to be bigger. Always. A is always bigger than B. And the shape of the ellipse changes depending on whether the bigger number is underneath X or underneath Y. You'll notice that this is very similar to the equation of a circle. So if you remember that circles have equation of the type r squared, right? Something like this, s squared plus y squared equals to r squared. The difference now is that have two radii. You have A as one radius and B as another radius. So you have to change the equation of the circle a little bit. But that's how I remember it. I remember this equation by remembering that it's almost a circle, except it's got two different radii, right? Yeah, so just remember this. It's very important to remember that A is the largest of the two denominators, and that where A is determines whether your ellipse is has the major axis on the horizontal, meaning it's longer on the horizontal, or it's longer on the vertical. Some important points. To find the foci, we'll call them, call their coordinates C, right, for the foci. And to find C, we use this formula here. C squared equals A squared minus B squared. So meaning you just subtract the two denominators, the bigger minus the smallest, take the square root, and that's your focus, the coordinates of your focus. Okay, so let's keep going then. Here's an example. Let's graph and locate the foci of this ellipse here. So we want to have, to write this equation in standard form, if you remember, the standard form has a 1 on the other side, so this should be a 1, this 144. So what I do is I divide both sides by 144 to make this work. So I'll go, let me zoom in a little, use our space better. So we have our 16, divide both sides by 144, plus 9 y squared over 144 equal to 1. But that's not good yet, because I only want x squared divided by something. And I can be clever. We've been messing with fractions a little bit to score. I can be clever and say that this is the same as 144 divided by 16, which is y squared over 144 divided by 9. The reason why this is true is because if I wanted to solve this fraction, I'd repeat the x squared and repeat the second fraction flipped. So I'd get exactly the same thing I started with, okay? So that's what I have. So my decision now, which of these two is the largest? So I've done it, right? It's in standard form. Which of these two is the largest value? So the largest value, so I have these two numbers here as candidates for A and B, A squared and B squared. The biggest one is A squared. So the biggest one, so let me say this. So the candidates, so let me say this. The largest denominator between 144.16 and 144.9 is 144.9, because the smaller bottom of a fraction gives me the largest number. So A squared is 144 over 9, which is the biggest always, and B squared is 144 over 16. So A squared is always the biggest. Okay, gotta remember that. So that means a equal to 12. So the square root, right? Take the square root over 9. And b equal to 12 over 4. Okay. So I can simplify that. So that's 4/3. And I can simplify that. And that's just 3. Okay. Oh, did I mess it up then? Give me a second. Divide by 3. Let me think about what I did wrong for a second, please. Oh, yeah, excuse me. It's 12/3. Correct that for a second. That's 12/3, right? Taking the square root of both sides. And then that will be 4. Okay. Okay, 4 and 3. A is 4, B is 3. Okay, so because the largest number, A, right, because this guy here is under Y, so because, this is my last step here, because A divides Y, the major axis on the vertical is vertical. So meaning, because the larger number is underneath Y, that means your ellipse is elongated vertically and not horizontally. So that means it looks a little bit like this, right? And not this. Okay, so I can throw this away. Okay, that's an important step on graphing ellipses. Okay, next, find the endpoints. Okay, so find the vertex. I haven't quite found the vertices yet, so let me add a page so that we can write more. So because I found that the major axis on the vertical, I start from the origin and I add A up and I add A down. So that means my ellipses, I haven't finished graphing yet, I'm just giving you a rough sketch. I don't have to do this in a problem. This is the major axis and this is the distance A. So that means this point is the point 0, 4, and this is the point 0, -4. So these are the vertices. (0, 4) and 0, -4. So I don't have to draw this thing. This is just a draft, so that I know what I'm doing. You have to write this though. Okay. So let's go. Find the endpoints of the horizontal minor axis. So just do the same with. So the minor axis has endpoints always. I mean, because it's horizontal, right? Because it's horizontal. I always add B and subtract B, but because it's horizontal, I do that on the x-coordinate. So -3. Watch. Let me check that if you give me a second. So this guy is the biggest one. The major axis is vertical. Yeah, right. You see that when A is underneath X? Yeah, I think this is a mistake of the book, of the slides. Let me go ahead and check my math to see if the slide's correct or incorrect. I think I'll write what I think first. And then let me go ahead and graph it on the calculator to see if the slide is incorrect. So it is, the original equation was 16x² plus 9y² equal to 144. Yeah, Wolfram Alpha agrees with me. So this was incorrect. I'm sorry about that. I thought I had fixed all of these. So it's these guys here, okay? And again, the reason why is because the major axis is determined by what has the major denominator, right? So the larger denominator, so go back to the equation, right? The larger denominator is this guy, so that's the major axis on the y direction because this is underneath y. The smallest denominator is the minor axis, so it's in the x direction, so I have to subtract and add b to the x direction to get the minor axis. Okay? Okay. So now I have all the information that I need. Let me correct what was wrong here. Oh yeah, there you go, so the other one was correct. You see, this is correct. There you go. How do I find the foci, right? Let's find the foci. So the foci are determined by c squared equal to a squared minus b squared. So c squared equal to 4 squared minus 3 squared. It's a and b that we just found. So c squared equals to 16 minus 9. So c squared equal to 7, right? So that means c equal to root 7. So to find the foci, and then again, that's a little draft. I know my ellipse is vertical. And the foci, because of that, they stand on the major axis, so they're here and here. So the foci are, so I'll say here, the foci are so they are 0, root 7, right? Root 7 up and root 7 down. Okay. And this is the distance of C, right? Same as below. So this is a little draft here. You don't have to write that part, but you have to write this. Okay, so now with all the information that was collected, let me correct this here too. We can start graphing our ellipse. So we have 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Start plotting them points. So the major axis is vertical. The vertices are 0, negative 4, and 0, 4. I want you to see all of these in your graphs, okay? I want to see the vertices. The endpoints are negative 3, 0. This guy. I think I can do this better. And then I have the negative 3, 0. And the 3, 0. So then I can draw the ellipse, right? Doesn't have to be perfect. The coordinates are what matter, and the shape of it. And then the foci. So root 7 is less than root 9, right? Root 9 is 3. And it's also more than root 4, right? Which is 2. So it's between 2 and 3. So it's here. I'll place it here more or less because I don't know exactly where it is. So this is 0, root 7. And this, I'll say this is F1. And less than 2 and 3. This is 0, negative 7. And this is F2. Okay? This is my first graph of an ellipse. You follow this step by step, you should be able to graph every single ellipse center at the origin. Now, sometimes you'll be asked to find the equation given the graph, right? Given the vertices. So that's what we'll do now. It shouldn't be too hard. So here's the idea. Go ahead and review what you need to review before you do this. If you're having trouble, I'll go a little bit faster after this. So we're finding the standard form of the equation of the ellipse with foci at negative 2, 0, and 2, 0. The vertices are these. So the vertices are given, and I know the foci, right? So if I were to give a little graph, little sketch, So let me fix it, because the 2 points. Let me graph the points first. That's -3, 0, and 3, 0. Right. So these are the vertices. So that means the longer axis, right? The major axis is in the horizontal. Okay, so that means the minor axes are vertical. So I have to find the minor axis. That's all I need to find the rest of the equation. And these are the foci, right? So this is -2, and 2 are the foci. So C equals to 2, and that means A equals to 3, because that's the major axis, right? So to find B is the only thing that I need for the equation. I use that C squared equals A squared minus B squared. And then C squared equal to, okay, I know what C squared is, it's 4. A squared I know is 9. And B squared I don't know. So I move B over here, and I move 4 over there. So B squared equal to 5. B equal to √5. Okay? So I just add the B to the left, subtract the 4, I get a 5, and then I get B. So now I just have to decide where B goes. So B squared equals 5, right? I had that already. I have to decide where B goes, where A goes. Does A go underneath X or Y? Well, the major axis is horizontal, so that means major axis horizontal means A squared divides X. Right? X is horizontal. So the equation will be X squared over A squared plus Y squared over B squared equals to 1. So it's X squared over A squared is 9, Y squared over B squared is 5 equal to 1. So that's the equation. Okay, so I use C and A to find B. I use what I know about the vertices to find that the axis is horizontal, and because the axis is horizontal, I decide where A and B go, whether they go under X or under Y. Okay. We won't need this page. Here is a little adaptation for when the ellipse is not centered at the origin. It's very simple. It's very similar to what happens when a circle is not centered at the origin. What changes in the equation is this little thing here, right? This minus h minus k underneath the square, right? So what you change is you pretend like hk is the origin, and you graph it exactly in the same way. So let's see if we have an example there. So I'll just note the little differences here. Here is the center change, right? So the center will be, so they say it there, so the center will be -1, 2. Remember that when you have minus h minus k, you gotta change the sign of that thing to find the center. So what you do is you start from that point, right? And you go however many units A and B tell you to go. So they found that, so A squared is the larger one, so A squared is 9, so that means A equals 3, and B equals 2. Because A is underneath X, right, that means it's horizontal, the ellipse, so it looks like this. Horizontal, but then you start from -1, 2. So you graph the center first. So this is -1, this is 2. -1, 2 is the center. Now that I know where it is, I'll expand a little bit my graph, my axis, right? And then because A is 3, I move 3 to the right. So 1, 2, 3. So this is one vertex. And I move 3 to the left. So 1, try and make a little 1, 2, 3. So that's one of my vertices. Alright, so this is the center. So this is the vertex 1, and this is the vertex 2. Zoom in a little, maybe that helps. And now I know B is 4, right? So these four go 2 up and 2 down. Okay, you can carefully find the coordinates of these points by following the steps that we did for the previous problem, but that's all that happens. You start from the center and you do the exact same thing. I'll let you follow this example along, okay? You can do the math yourself here and find these guys, find these points. And then you're all good to go because we've already found the center. Okay, it's not that bad. Okay, here's the result so that you can compare it. And you can see that the vertices are given so that you know the answer. Let me know if you have trouble with this. Let's solve an application, and then that's going to be it for this video. So let's read this. We have a semi-elliptical archway over a one-way road that has a height of 10 feet. So here's the drawing there, 10 feet. And a width of 40 feet, so there's the entire archway. So will a truck that is 12 feet wide and has a height of 9 feet clear the opening of the archway? So the truck is 9 feet high, right, 9 feet tall and 12 feet wide. So is the truck going to clear, right? Is the truck going to be able to drive underneath the archway? So let's treat this problem carefully. So what you do first, you place a coordinate system on that. Because you're handling ellipses, the best way to handle ellipses is through having a coordinate system and an equation. So you go ahead. So it's going to be the ground for me. Now place my ellipses here. So my ellipses is 40 feet wide. So I'll place my coordinate system in the middle. So my x and my y. So that's going to be minus 40, 0. Excuse me. So it's 40 feet wide. So that means it's 20 to the left, 20 to the right. So this is minus 20, 0. And this is 20, 0. Okay. And then because they say it's 10 feet tall, right? 10 feet. The height of the archway is 10 feet. So this is the point 0, 10. Okay, so I can already find a lot of stuff about this ellipsis. For example, I know the major axis is horizontal. Because it's the largest, right? That's what major means. So that means A goes underneath X. So that is A. This distance is A. Mute my phone real quick. And A divides X. So the equation is going to be X squared divided by A squared plus Y squared divided by B squared equal to 1. So A is 20. Right? A is this guy. This is A. And this is B. So then X squared divided by A squared. 20 squared is 400. Y squared divided by B squared. 10 squared is 100. That's the equation of my ellipse. Great. Great, right? I found the equation that describes my ellipse. So now, next thing. Let me place the truck. So here's the truck. So the truck is 12 feet wide. So let's say the truck is driving through the middle of the road. The truck is going to drive through the middle of the road here. I don't know if it's shorter or taller than the archway, but I'm just drawing like for comparison purposes. So because the truck is 12 feet, so this has to be 12 feet. And the best chance that the truck has to go under the archway is to stay right in the middle, meaning this has got to be 6, 0, and this has got to be negative 6, 0. Okay, 6 to the left, 6 to the right, right in the middle. Okay, so my question now is this height at x equals to 6 larger or smaller than the height of the truck, which is 9 feet? Okay, Think about it for a second. Understand that. When x equals to 6 is the height of my truck, larger or smaller than the height of my archway. I know the height of the truck is 9, have to find what the height of the archway is at that coordinate. So that's what I'll do next. So at x equals to 6 is the archway tall enough or high enough height, I'll say, larger than 9, which is the height of the truck. And that's the question, right? So I'll take my equation and I'll plug in x equals to 6 and I'll find out what y is, and that's going to be the height. That's 9 squared over 400 squared plus y squared over 100. So that's, I'll move this over to the other side, zoom in a little. So that will be y squared over 100 equal to 1 minus 81 over 400. So y squared equals 100 over 100. That's 400 divided by 400 minus 81 over 400. That's y squared over 100. That's 319 over 400. And now I multiply by 100. So then I get y squared equal to 319. So I can cross these zeros out too, right? When I multiply it out, that's over 4. So y squared equals to the square root, so y rather, right, equals the square root of 319 over 4. I use my calculator for that because 319 does not have an exact or a whole root. So I use my calculator to compute what's the square root of 319 divided by 4. Let me know at any point if you're confused with this. And then y is approximately 8.93, which is less than 9, which is what I needed it to be. So yes, the truck can drive past the highway, or past the archway. So this is something you have to consider whenever you're building that kind of structure. There are already existing trucks or other things that you have to consider. Okay? So the answer here is yes. So that's it for this video. Make sure to practice these problems. There are some practice problems on ellipses on, I'll give you the page, very close to what we'll have in the homework assignment. So if you go to the review exercises, so we can go to page 1035, section 9.1, review exercises. Should be able to finish them all. Just solve as many as you need. Okay? Stop right now. Thank you for watching that.